assume now that the post correspondent problem is a decidable. We will assume, but obviously it is not it is undesirable. So if it is decidable, then we can construct a machine shown in a figure. What is in the figure? A universal language LU. If it is given to an algorithm, that will provide a MPCP solution. Again, if it is given to an algorithm, we can able to convert into a PCP solution. So this machine clearly decides that the MPCP problem, but the MPCP problem is undecidable. Consequently, we cannot have an algorithm for deciding the PCP problem. Okay, so how to handle this? So here, for handling, that is for converting a Turing machine into an MPC problem and for inserting all those symbols, this is the procedure. Okay, so here what they will be doing, that they will be stick on with 5 rules, 1 2 3 4 5 rules. So the first rule is, so let us consider a Turing machine. Q, set of state, sigma, set of input state, gamma, set of stack symbol, delta is your transition, Q naught is your initial state. Here instead of blank, we are using hash. So instead of blank, we are using hash, and F is your set of final state. Now, as like your PCP problem, we need to create two lists. Okay, so we how to create the list in a Turing machine transition. That's what we are going to see. So as I said here, initially we will be creating a zeroth like state. That is, if it is, you start from 1 means 1 minus 0. Likewise, we have to find the zeroth state. So likewise, in Turing machine, the first, always the first pair is, in list A, it is blank. In list B, Q naught. Q naught is the initial state, and W. W is the input string. For example, if I'm adding two numbers like 2 plus 3, my input string is like, if I'm using like 0, 1, 1, 0, 111, 0. So this must be my input. Likewise, if I'm going to A and B and likewise means accordingly, like A, B, B, that will be my input. So this is my W. So initially, list B, both side blank, insert Q naught and W. Okay. Then the second rule, tape symbol and the separator. So what are all the tape symbol you have? What are all the tape symbol you have? For all the tape symbol in my gamma, you just write in list A also that particular symbol, B also. So if I'm having A here and put a A here. Likewise, you put finally hash hash. Likewise, you create the list for tape symbol. Okay. Then the moves, stimulation of the moves, that is very much important. So for example, if I'm having a move like delta QX, so I'm in Q state, I'm reading X, then I'll be transferring to P state to P state, and my X will be written as Y, and I'll going in right direction. So I'll be going in right direction. So QX means what happened? I will be going in right direction. So this will become P, and this X is changed into your Y. So that's what in my list B. And next is, okay, fine, I'm the same transition. What happen if I'm going in left direction? So QX. So if I'm going in left direction means this Q will be going over here, which is P, fine. But here there must be some symbol. Am I right? There must be some symbol. So what happened? This Q will be gone over here with P, and this symbol should be coming here, and my X is changed into Y. So likewise, like your ID, instantaneous descriptor, these moves need to be stimulated. Then Q blank. Now Q state, I have a blank in front. So if that is the case, I will be changing into P state, and this blank is converted into Y, and I am going in the right direction. So what happens actually? Q blank means this one will be going over here, as P, and also here also there will be a blank anyway, so P blank, and this blank is changed into Y. Similarly, if I am going in left direction, there must be some symbol over here. So this will go over here with the P, that is my state name. So P Z, and this will be changed into Y. So Y, and after this, obviously there will be a blank. So that blank has to be stimulated over here. This is my third rule. All my moves. Then fourth, finally accepting. So there must be some accepting state, no? So if there is an accept state, so if my Q3 is an accept state, if my Q3, so we have seen the first list, the tape list, the movement list, then finally accepting list. So if my Q0 is my accepting state, if my Q0 is embedded between any symbol or it in the last or in the beginning, whatever it is, my list B will have Q, that particular Q. And like my initial state, rule 1, I'll be having my final state where here as I put hash Q not W hash, here I'll be having Q hash hash hash. Likewise, I will, for a Turing machine, to convert that into an MPC problem, we have to create two lists. After creating two lists, we have to find a combination such a way that we have a same solution, so that both left hand side and right hand side has the same set of formation of strings. So this is a very traditional problem. Okay, so consider the following Turing machine. So they have given a Turing machine with three state Q1, Q2, Q3. The symbols are 0, 1, and my tape symbols are 0, 1 and blank, delta transition. Q1 is my start state, so this is my start state, and Q3 is my end state, so this is my end state. And here I used blank, not hash, I think. So no, hash only. So I will change it into hash. I don't want to confuse you. Hash. So my blank symbol is hash. Okay, done. Okay. So first, what they say that first convert this problem instant to MPCP form. Then to find a solution, so they have given the string as 0. Input string is 0. We can start this the partial solution that mimic the computation of M and eventually leads to the solution. So how to solve? First, as per their rule, we need to create this table. Okay, so this table is being created. It's very simple. So this was the set of rule. So I have kept it in the this left right hand side. By seeing this, you can easily understand. Let me take a pen. Okay, so the first rule is hash Q not W. So here hash, here my according to my problem, Q1 is my start state. So hash Q1, and the input string they have given is 0. So 0 hash. Then the rule 2 is for all the tape symbol, both side I have to put a ditto copy. So my tape symbols are like 0, 1 and hash. So 0, 0, 1, 1 hash hash. So as my rule 2 is being completed. Rule 3 is movement, the transition. So I have this much of transition. So I'm taking the first transition when in delta Q naught of 1, it goes to Q2 1R. So for this we need to think of. So what they have said, Q naught of 0. So Q1 0 means that 0 will be converted into 1, and I'll be going in the right direction. So this will be going over here, Q2. This 0 will be converted into 1. Simple. Next is Q1 of 1, which is Q2 0 left. So left means it will be going over there. So Q1 1, that is fine, but in the left hand side I might have 0 1, or I might even have an hash, because I need to, this Z could be all the tape symbols. So if it is 0, what happened, I'll be going here, it will be changing to Q2. This 0 will be the same, but this 1 will be converted into 0 according to the transition. Always this 1 is changed into 0 according to the transition, but in the left hand side or in a problem, it might have a 0 or 1 or a hash. So only this much combination I have written. Okay, next one is Q1 of blank is Q2 1 left. So Q1 of blank is Q2 1 left. So left means again I have to consider 0, 1 and hash. So you can see 0, 1 and a hash blank. So this blank is being converted into 1. So 1, then again I put an extra blank also. And this is been moving over here with Q2 as a state. So Q2 0, 1 hash, Q2 1 1 hash, and Q2. So as I will be moving over here, Q2 hash, this hash is being changed into 1 and then hash. Do you understand how this table is being created? It's quite tricky, but this is an important part in your PCP problem. The next transition is Q2 of 0. So Q2 of 0 is Q3 0 left. So again it will be going in the left direction. So Q2 of 0 in its left direction, I may have 0 or I may have 1 or I may have hash. But this 0 will be same the 0. So Q2 left, where this will be the same. So 0 0 0, and I have included in a hash over here. That's not necessary, maybe I have included it. Next one is Q2 with 1. It is Q1 0 right. If it is right direction, we have only one thing to be considered. But when it is left direction, how many gammas are there? Symbols for that all gamma symbol we have to think. So here it is no problem. So Q2 right, it will be going over here with Q1 and 1 will be converted into 0. Similarly here Q2 blank, Q2 0 blank, the blank is converted into 0. So here same state Q2, but this is converted into 0 and we will be having another hash. So by seeing this set of rule, for this particular problem, this list A and list B was created. You have now rule 4. So rule 4 is very simple. So they in the problem itself they have given to me my final state is Q3. Okay. So according to my rule 4, if the Q3 was there in any combination, my list B will be having only Q3. So I have written all the combination, either 0 0 or 0 1 or 1 0 1 1 or here only 0 1 or with a blank. So all the combination I have listed and I written if this was my list 0, my list B will have only Q3. This is my according to my rule 4. And my rule 5 finally is like Q3. This must be my final state. So Q3 hash hash hash. So Q3 hash hash hash. So with the help of the set of rules given, I have converted my Turing machine into a tool list. So now for this tool list, so this was the entire list. Now for this tool list, we have to create an like a transition. Okay. So if I'm simply writing an ID by seeing that transition table, like a Q1 with the input of 1, I think here I have written with the input of 1. So if I'm simply writing that ID with an input of 1, what happened like a Q1 1. So in Q1 state, if it is 1, in Q1 state it is a 1, it will be going to Q2 0. So left direction. So left I have a blank. So this will be going over here. So Q2 hash 0 and Q2 with a blank. Q2 with a blank means what? Q2 with a blank means that blank will become 0 and going in the right direction. So this will become a 0 and I will be going in this right direction. So this is my state. Then Q2 0 is Q2 0 means Q3. So I will be ending up likewise. So I'm going to my final state. So this is our general ID for my Turing machine. Now let us try for my problem. So here hash. Okay, fine. That is my list. I think this is my entire list hash. And Here I'm using Q11 because that was the input given. So Q11. So for Q11, that is in my initial state, 1 as my input. So Q11. So for from the list Q11, what was the available list B for Q11 hash Q1. For hash Q1, you can see here I have this combination. For hash Q1, I have this combination. What combination I have? For hash Q1, I have like Q2 hash 1 hash. So for Q1, 1, I have like Q2 hash 0. We may now further, wait, Q2 1 0. It should be Q2 1 0. Q1 hash 1, Q2 1 0. Wait. So hash Q1 1, hash Q1 1, hash Q1 1, where it is hash Q1, here it is. For hash Q1 1, if I am having hash Q1 1 and list A, my list B is Q2 hash 0. So Q2 hash 0 is what was there in my list B. So I will be adding in my list. So I will be adding that into my list. So for this combination, this was my list. Then again for Q2 hash Q2 hash, for a hash Q2 hash, again I will be searching hash Q2 hash. So this is the only combination I'm getting, 0 Q2 hash. So for hash Q2 hash, 0 Q2 hash is main coming. So likewise, I will be transferring. So these we may further, that is we will be with this as an, this is my first list, then this is my second list. Next I'm just adding this. Then after here, by seeing this, I'm just copying over here. So the list the list B copy the content of list B. Then by seeing this value from the table, it is going over here. So the next value is getting copy over here. Then again by reading this, the next evolution take place. But here it will be getting copy over here. So likewise, what rule is being applied, I have noted over here. So list A and list B are getting evaluated. The thing is that here we start only with a hash, but here we start with hash Q1 1 hash. And finally, while you are ending, so by seeing that Q3 0 hash, Q3 0 hash, in the ending we have specified that in list A it should end with Q3 hash hash, and here we have simply have Q3 hash. So here we have one hash. By adding that, both the side becomes equal. With only Q3 left in the ID, we can use Q3 hash hash comma hash, the final thing, by applying rule 5. And finally, both sides will be having the same set of solution. So this problem have an MPCP solution. Likewise, we need to conclude. So this is an MPCP problem for a Turing machine. So they will be giving you a Turing machine. So you need to create a transition table, and accordingly, as per the rules, you need to frame two lists. And for the given input, if the input was given, you need to create this two list of table, and you have to conclude that both the side has the same set of strings. So it's an MPCP problem. So this was the concept coming under MPCP. So MPCP is most probably used to actually most probably used to reduce a given undecidable problem into a PCP. What is PCP? PCP provides an intermediate result for an undecidable problem. So converting a given entire Turing machine into a PCP problem, that is a one with some answer, is quite complicated. So what they have done is they are converting a given problem into an MPC problem, and they are specifying that if we have a solution for an MPCP, obviously we will be having a solution for a PCP. So here for a simple Turing machine, we have seen how we just reduce that into an MPCP, created a two list and try to compare those two lists with a given string, And as we have a solution, we can specify that, okay, we can have some intermediate PCP solution even though the problem is an undecidable problem.